and we move on to the next set of 3 questions. The ratio of the number of sheep to chickens on a farm is 3 to 5. In spring, 6 sheep are born. The new ratio is 9 to 10. How many chickens are there? So this is a fairly classic type problem, and the way I would always set this up is algebraically. So sheep to chickens, so S to C is equal to 3 to 5. And then when 6 sheep are born, so S plus 6 to C, no chickens have changed, is 9 to 10. That's the information they tell me. Sheep to chickens is 3 to 5, and then when 6 more sheep are added, S plus 6 to C is 9 to 10. That will give me 2 equations, therefore. What a ratio is telling me is the proportion of S to C is the same as the proportion of 3 to 5. So S over C is equal to 3 over 5. And similarly here, S plus 6 over C is equal to 9 over 10. So I have 2 equations and 2 unknowns, so I can now solve for C and S. I'm going to take an elimination approach, so I'm going to rearrange this to make S the subject by multiplying by C. So S is 3/5 of C, and then I'm going to sub that in here. So if that's equation 1 and equation 2, I'm going to sub it in equation 2. So I get 3/5 C plus 6 over C is equal to 9/10. I don't like my unknown being in the denominator, so I'm going to multiply by C, and I'm going to multiply by 10 as well, because why not? 3/5 multiplied by 10 is 6. So I get 6C, 6 multiplied by 10 is 60, is equal to 9C. I can subtract 6C from both sides to get 60 is equal to 3C, and divide by 3, C is equal to 20. So there are 20 chickens. That's why I decided to get rid of S instead of C, because I'm only trying to find out how many chickens there are. If I wanted to know how many sheep there were, I could then sub 20 back in here. 3/5 of 20, which is 12. And indeed, you can see the ratio works in that setup. And that's how we'll approach all ratio questions where you're trying to find unknown quantities. Question 10. Solve the equation, then there's a quadratic, give your answer to 2dp. As soon as I see that, I'm thinking, well, factorising is unlikely to work in that case. Quadratic formula. And as long as I've got my formula, calculator, and I can remember my formula, or in this year's case, I have the formula book, I can solve fairly easily. I could complete the square as well, but why bother wasting my time? Your quadratic formula is x is minus b plus or minus root b squared subtract 4ac all over 2a, where a is the coefficient of x squared, so 2, b is the coefficient of x, so negative 7, and c is the coefficient, or the constant term, the coefficient of your x to the 0, effectively, so positive 4. So minus b, negative 7 is positive 7, plus or minus the square root of b squared, negative 7 squared is 49, subtract 4ac, 4 times 2 times 4, all over 2a, 2 times 2 is 4. Now I'm showing the examiner very clearly what I'm typing in, and I'm even going to simplify that a little bit more. So I'm going to do 49 subtract 4 multiplied by 2 multiplied by 4, which is 17. So I have 7 plus or minus root 17 over 4. They want this to 2 decimal places, so I'm going to do first 7 plus root 17 all over 4, which is 2.78 to 2dp. And I'm going to do the same thing, but I'm going to change my plus to a minus. And that will give me 0.72, again to 2dp. Our next question looks at cumulative frequencies. Cumulative frequency. The number of glasses of water drunk by 50 people in a day is shown in this table. Ethan uses the information to draw a cumulative frequency graph. Write down 2 mistakes he's made. I don't like these questions. I find it quite hard to do this efficiently in an exam when it's only worth 2 marks. So my advice is just attempt to draw the cumulative frequency graph yourself and see what's gone wrong. So the first thing I would do is I would label my axes. I've got a label, and they're the correct way round. Then I would pick a scale, making sure my scale goes up by the same amount each time. It does in this case. Then I would plot. There are no people that don't have any glasses of water drunk, and then there are 6 that have 4 drunk. So no people is good, but then this 6 here should be on the 4, because I don't know whether those people are at the midpoint or at the end point. So for a cumulative frequency graph, I always plot at the end point. So mistake 1, plotted points at midpoint rather than end point. So I'm covering all my bases there. I'm telling them the mistake and I'm also correcting the mistake. That seems pretty good. The only other thing I'll check now as well, joined with straight lines, which they are. So probably he's plotted a coordinate incorrectly. So let's have a look. 6, that works. 15, 16, 17, that works. 32, I can't see that at the moment because I need to work out my cumulative frequencies. I apologise. So 6 plus 11 is 17, that's why I knew that one would work. Adding 17 is 34, so we found our mistake actually. Just for completeness' sake, 47 and then 50. Tells me I've done it right because there are 50 people. But there you go. So when I get to 10, which is going to be this interval here, I should be at 34 and I'm only at 32. So I would say plotted 8 less than n less than or equal to 12 at 32, but should be 34 again, pointing out the mistake and also the correct answer that should have been given. And that's how I approach those questions. If I were to do this, what would I do? Where is he disagreeing with me? And that's another few questions sorted.